Hello everyone, I'm Kaushal Kumar. In last session, we talked about intelligence. Artificial intelligence at a very higher level, where we talked the types of or the components of artificial intelligence, where we talk machine learning, deep learning, and AI. Now we will talk more in detail of machine learning and its components. Let's have a look together. Here you can see machine learning divided into some segments: supervised learning, unsupervised learning, semi-supervised, reinforcement, and self-supervised. Don't be confused. I will explain each topics in very detailed way. First, we will try to understand what exactly those terms, and then we will move for the practical. In supervised learning, we work with the label data. So what it means by label data, I will explain this also. And the supervised learning, the main goal of these algorithms is they learn from known input and output. So it's a kind of machine learning where model learns from label data, means every input has a corresponding correct output. The model makes predictions and compare them with true outputs, adjusting itself to reduce the error and improve the accuracy over the time. So in next session or in continuous session, we will talk about how to train the model. But let's understand at a theoretical level what exactly the supervised learning is. Some examples of supervised learning is predicting house price. Let's say you have a data where we have some parameter which are deciding factor for house price, and spam detection of the emails. So this model trained from our data where we labeled, let's say, which email. If we talk about the email, what is definition for spamming, and if we talk about house pricing, then that data is a deciding factor in that. So first we train our model with input and output and then ask for the prediction. Let's have a look in the example. Here you can see an example of supervised learning. We have data set. That data set contains several shapes. Those shapes could be circle, rectangle, squares, etc. And we know the labels. So we have defined three labels here: square, triangle, and circle. So what is the shape of circle? What's the shape of triangle? What's the shape of square? And then we provide the training of our model. So our model will take training from these labels and try to predict the correct output when we provide the shape as an input to this data. So the first action is we have raw data, and then we will train our data with the known labels. This training will given to this model. Then we will have a data, and the data generally divided in two parts. One is train set and another is test set. And then this model will give us the predictions when we add the input image, for example square. Then this model will give us output its square or its triangle based on the data which we provided at the time of training of our model. Where other side we have unsupervised learning. So unsupervised learning, as naming suggests, it's completely work with unlabeled data, which itself discover hidden patterns or group in the data. The examples for unsupervised learning is customer segmentation, anomaly detection, and we have a hybrid. Hybrid means semi supervised learning, which is a combination of supervised and unsupervised. This means we have data which are partially labeled and partially unlabeled. So the semi supervised machine learning type comes here, which combines the small labeled data and large unlabeled data. The real world examples could be medical images, classification with a few labels. And again, next term in the machine learning comes reinforcement learning. It's called reward based learning. This means we train our model, then model will gives us output or predictions, and then we fine tune the model based on the rewards and penalties. That's called reinforcement learning. For example, game in AI, self-driving car, robotic controls, these are some examples for reinforcement learning. Another term is self-supervised learning. That's the data used here generated labels. The goal is predict parts of data from itself. As everybody is knowing the word in the market or nowadays in the era is called LLM, large language model. For example, Chat GPT, Gemini, etc. Yeah, these are self-supervised learning models, those called LLMs. We will dig it down more in detail. So our first topic, I will start to self-supervised learning. We will learn what is supervised learning, how we can make our model which will provide the predictions. So there are some algorithms which works for supervised learning, like regressions and classification. Let's have a look here in the pipeline. As you are existing .NET developer, you know when you develop your application, then there are certain stages for developing an application. So it's called application lifecycle. Similarly, in the machine learning, we have machine learning pipeline, which is structured end-to-end workflow that automate and organize the process of developing, training, validating, and deploying machine learning model. So let's have a look how machine learning pipeline works. So we will have raw data, then this raw data will be collected, or you can say this raw data would be loaded, and then we will perform pre-processing for the raw data. Once pre-processing done, this means normalization. Think about SQL Server tables or any RDBMS database where you remove the junk data. So data pre-processing is very important in the machine learning models. If we don't perform the pre-processing or we don't clean up our data, then there would be higher chances that our model predict wrong output. So that's why this pre-processing plays very important role for ML developers. When you need data, generally your machine learning models needs data. It doesn't care your data is clean up or not clean up, but this is our primary responsibility. To work with the machine learning model, we provide clean data to the model. So there is a one step is called pre-processing, where we uh, clean up our data for missing values, removing duplicates values, encoding, normalizations, and then we perform feature engineering, where we perform transformation. I will talk in the next session or maybe this session what is feature engineering. Once this feature engineering done, then we choose the model or the algorithm, which algorithm fit for our model. So the algorithm would be there. Then we check the evaluation of the model. Here it's a predictions. Once you are satisfied with the performance, or once your acceptance criteria for the model is fulfilled, then we will deploy the models. So this is the theoretical part. What exactly machine learning types, what types are available, and then brief knowledge I shared to you about each machine learning type. Now we will delve into practical part, where we'll see how we can start working with ML.NET with using machine learning algorithm.